Good morning. So we're going to do the last bit of review for your quiz coming up on relations and functions. We have domain and range was what we finished up with, and we're going to just do one review. So let's see if we can find something that's interesting here. Why don't we do B? Because B is a little bit odd looking. Remember, when you're looking for domain, you're looking for the extremes to the left and right. Range, you're looking for the extremes up and down. Because domain has to do with your X, which is the left-right, and range has to do with your Y, which is the up-down. So we'll start with domain. Again, just always look, what's the furthest to the left? It's right here. And the furthest to the right is right here. So that means your domain goes from -3 to +3. So again, squiggly bracket, X, such that, and we said it's between -3 and +3. X has to be greater than or equal to -3. Remember, we have a filled in circle, so that means that the edges are included. So -3 and less than or equal to +3. And again, because we have a solid line, we say that X is an element of the set of real numbers. Okay? Now, once you've got your set builder notation, the interval notation is easy because you're always using the same numbers, okay? Because X can be equal, we use square brackets, -3, comma, +3, and again, square brackets, and we're done. For the range, rather than looking left and right, for the range we look up and down. So there's the highest, there's the lowest. So our range is between +4 and -3. And again, this time we use a Y, right, for the range, such that it's between a low of -3, a high of +4, has to be greater than or equal to -3, less than or equal to +4, and again, Y also belongs to the set of reals. Finally, for your interval notation, we use square brackets because Y can be equal to the extremes. Lowest number, highest number, done. Finally, is it a function? Well, again, remember I said in the last video, if you've got a graphed line, it's easy. It crosses, a vertical line crosses twice, so it's not a function. Remember, it can only cross once in order for it to be a function. Okay, speaking of functions, we're going to move on and we're going to take a look at function notation. Now remember, there's nothing particularly scary about function notation. For instance, here's an equation you should all be familiar with because it's exactly the same as this one. Okay? Remember, f at x is just another way of writing the variable y. So this, remember, is called an equation in two variables. Whereas this is referred to as function notation. In terms of how you deal with them mathematically, they're pretty much the same. Okay? So, what this is saying to you is find y when x equals -6. Okay? So we'll do that. So, when we're given a value for x, we simply sub it in on the other side of the equation, and it becomes negative 4 times negative 6 plus 3. Okay? Notice I've just taken that negative 6, I've plugged it in wherever I saw x on the other side, and then you just simplify. Negative 4 times negative 6 is positive 24 plus 3, or 27, and you can think of these two values as an ordered pair, where you have an x value of negative 6 and a y value of 27. Okay? If you see something scary like this, don't be scared. All that means is wherever you see x in your original equation, you're going to plug whatever value you see in the brackets. So this one would become negative 4 times 2n plus 3. Again, that's my value for x, so I plug it in wherever x was. And then I simplify. Negative 4 times 2n is negative 8n plus 3. So f at 2n simply equals negative 8n plus 3. Can't simplify it anymore. These are not like terms. Okay? So, don't be scared. It's just something a little bit different than what you're used to. Okay. We then went on and basically did the same thing on a graph. Okay? So, what they're really asking you to do is come up with a point. Okay? So they're saying, what would the value of y be when x equals negative 4? Remember, this value in brackets in your function notation is always your x value. And they're saying, when x is negative 4 on your graphed line, what does y equal? Well, go to x equals negative 4 and see, where does the line cross x equals negative 4? It crosses right here. And so our ordered pair will be at negative 4 and positive 1. So f at negative 4 equals positive 1. And our ordered pair would be negative 4 and 1. Okay, we'll just do one more. How about positive 4? When x is positive 4, y is right here, and you get the ordered pair. X is 4, y is 4. So f at 4 equals 4, resulting in the ordered pair 4 and 4. Okay? Now, you'll notice that for number 14, it looks kind of similar, but for number 14, they're not giving you a value for x. They're not telling you what x equals. They're actually telling you what y equals. So when they say f at x equals 4, what they're saying is, here's the value for y, figure out the value for x. The way you go about doing it, though, is exactly the same. For a y value of 4, there's our y value of 4. There's where the line crosses that, and it crosses it when x equals 1. So that means our ordered pair will be 1 across and 4 up. So f at x equals 4 when x equals 1. Okay? Now, sometimes, let's look at E. We have f at x equals 0. So again, remember, this is your y value. And they're saying, what will your x value be when y is 0? Well, if you take a look at the graph, you'll see here's a place where y is 0, but here's another place where y is 0. So again, don't be scared. You can have two correct answers. So When f at x equals 0, you have this point here at -1 and 0, and you have this point here at 3 and 0. Okay? Again, do not be scared. You simply have two correct answers. In this case, your x values can either be -1 or +3. Two right answers. Okay? We'll do a couple of questions that are word problems that simply use this function notation. Okay? And then that'll be it. And we'll be finished the review, and you will be ready to do awesomely awesome on your test. So, this one says, the formula for calculating the value of $500 deposited into an account earning 8% compounded annually for n years, words, is, here's the important point, A equals 500 times 1.08 to the nth exponent. Write this formula using function notation. Now remember, we said if you have an equation in two variables, a y and an x, or an a and an n, it doesn't matter what the variables are. One is isolated, the other one is on the right-hand side, just as you see here. One is isolated, the other is on the right-hand side. We said you can write this in function notation very easily. Instead of y, you simply write f at x. The right side doesn't change. Okay? So notice, we took the variable from the right side, we stuck it in brackets. -4x plus 3. Well, we're going to do exactly the same thing with this. Okay? We're going to take the variable that was on the left side, the isolated variable, and instead we're going to write it as f at, and then we'll take the variable from the right side and plug it in. So instead of a, we have f at n. The right side doesn't change. 500, 1.08 to the exponent n. And that's it. Okay? Not too difficult. Number 16 says the function c at n equals 50 plus 15n. Again, remember, the variable on the right side is just plugged in the brackets for function notation. Describes the cost of t-shirts for basketball team where n is the number of t-shirts, c is the total cost in dollars, determines c at 12. Remember, that means find the total cost for 12 t-shirts, remembering that n is the number of t-shirts. Okay? So c at 12 equals, wherever we see n, we're now going to plug 12. 50 plus 15 times 12. Okay? So, simplify the right side. 50 plus 15 times 12 is what, 180? So c at 12 equals 50 plus 180, $230. What does this mean? 12 shirts cost $230. Okay? For B, they're doing it the opposite way. Instead of giving you a value for n, the number of t-shirts, they're giving you a value for c at n, the total cost. So they're saying, really, how many t-shirts would you have to buy, n, if your total cost, c at n, were $290? Okay? Just let me do some erasing. Okay, so they're saying c at n equals 290. In other words, if our formula is c at n equals 50 plus 15n, if they're telling you that c at n is 290, that means this variable, total cost, on the left side is 290. equals 50 plus 15n, and then we just isolate the variable, okay? Remember, you do the opposite of the normal order of operations when you're isolating. So the first thing we want to do is adding and subtracting. We'll take away 50 from both sides. That gives us 240 equals 15n. And what would that be? I guess 8? No, it's not 8. Oh, I'm going to have to get my calculator. 16. 16? 60? Yeah. Okay. So divide both sides by 15. And that gives us a value. We'll put it over here. 16 equals n. Okay? And again, what does that mean? It means the cost of 16 t-shirts will be $290. Okay? Okay, we'll do this one question and then we are done. Oh, let's just finish up C here. It says write this function as an equation in two variables. So this is the equation from number 16. If we want to write it as an equation in two variables, that's easy. Instead of this function-y looking thing over here, we can just say one variable, total cost, equals 50 plus 15n. Again, the only difference is instead of the function notation on the left, we've replaced it with a variable. This is called an equation in two variables because it has two variables. Okay? So equation in two variables, function notation. Okay, very quickly, for a single membership, you pay $60 for initiation and then $40 a month. The total cost written in function notation is C at M, the total cost, equals $40 for every month plus your $60 initiation fee. So, if you take out a membership for 0 months, they're going to charge you $60. If you take out a membership and you have it for 2 months, that's going to be 60 plus 40 times 2, right? Or 80 plus 60 is $140. If it's 4 months, that becomes 60 plus 40 times 4, 220. Oh, yeah, that's right. Is that right? That's right. For 6 months, 4 times 6 is $240 plus 60, 300. And for 8 months, it's 320 plus 60, $380. Okay? So we filled out our table of values. Again, note, this is always the independent variable. It's time, right? Number of months. This is the dependent variable because your cost depends on how many months. So we've completed the table of values. Are the data discrete or continuous, and explain? Well, in this case, with this explanation, you can't really take out a membership for 1.5 months or 3 2/3 months. So you don't have possible in-between values here, and therefore it's discrete. Why is it discrete? You can't join for a part of a month, a partial month. Identify the independent variable. Well, look at us. We already did that. So the independent variable is M, the number of months. graph the relation on the grid provided. Just give me a second here and let me copy this stuff down. So we had 0 and 60, and then 2, 4, 6, 8. So we've already said our independent variable is time. So number of months. Another way that you could have written it is simply as time in months. Either of these would be acceptable. We'll start at 0. We'll go up 1 month for each grid space. So 2, 4, 6, 8, 10 months. And for our dependent variable, we have cost in dollars. And let's see, let's go up by 20s. So $0, $40, 80, 120. Oh, I hope I have enough. 160. No, I'm not going to. This is what happens when you just guess. So we'll go up by 40s, say. 40. I just did that. Oh my goodness. Let's go up by 60s. 60, 120, 180, 240, 300, 360, 420. Okay, good enough. Plot your points. At 0 months, we pay $60. At 2 months, we pay $140. At 4 months, it's $220, so $220. At 6 months, it's $300. And at 8 months, it's $380, $360, $380. Now, because we have said that this is a discrete relation, we don't join the points, right? Now, there are other points, like there would be a point at 3 months, which would be in between here somewhere, but there's no point that's, say, at 2.5 months, okay? So we can't join these points because we have a discrete relation, okay? Is the relation a function? Well, can you drop a vertical line through here and only go through 1 point? Is there any place where a vertical line would go through 2 points? And your answer is no. State the domain and range of the relation. Now, we're going to assume that our maximums are the maximums they gave us, right? At 8 months and $380. So our domain and range, our domain would be, and I'm just going to use interval notation because I'm feeling lazy. The lowest domain value is 0 months. The highest domain value is at 8 months. For your range, the lowest range value is at $60 and the highest at $380. Okay? Determine the value of C at 24. Well, that means find Y when X equals 24. So, C at 24 equals 60 plus 40 times 24. Okay? So this would be a 24-month membership. So this is going to be the cost for 2 years. Okay? So that becomes 60 plus 40 times 24 is $960. Okay? 60 plus 960 is 1,020. So what does this mean? Cost for 24 months is $1,020. Algebraically determined. Remember, whenever they say algebraically, it means you have to show your work, you have to use the equation. Okay? So, they're saying find M if C at M, your total cost, is 580. So that means your left side variable, your Y variable, or in this case your cost variable, is $580. Find out how many months you would have to be a member if you were to pay $580. So then our equation becomes C at M, which is 580, equals 60 plus 40 M, 40 months, right? Or $40 per month. How many months would that be? We just have to isolate it. So we're going to take away 60 from both sides. That gives us 520 equals 40 M. Divide through by 40 on both sides. 40 divided by 40 is 1. You're left with M. 520 divided by 40 is 13. Okay? So for a 13-month membership, you are paying $520. Finally, write C at M equals 40M plus 60 as an equation in two variables. Nothing could be easier. Just replace your function notation on the left with a regular old variable. We'll use C because we're talking about cost. C equals 40M plus 60. We're done. You are now prepared for your test. Enjoy your studying. Bye.